Okay, so let's get into our first bit of content. I know on Monday I give you like life advice and stuff, but now we have to learn R and computational statistics and stuff. First, let me give you just some tips and advice on getting RStudio set up in such a way that I think is useful and handy. And so one thing is when you do your homework and stuff, and some of you have already like done your first homework assignment, which good for you, but that was not expected. When you do your homework, I recommend you create a little folder on your computer and you put all of your related files into that folder, okay? And don't put it in your downloads folder, all right? So, you go on the web browser and you click the button and it ends up in your downloads folder, but don't do your homework in the downloads folder, okay? Move those files somewhere else on your computer and make a little folder. So I recommend making a folder for homework 1 and putting your homework 1 files in there, and then make a folder for homework 2 and put your homework 2 files in there, and then make a folder for homework 3. And you guys get the idea, okay? And so when you, so here I have a 102A folder, and then within 102A I have a folder for homework, and within homework I have a folder homework 1, okay? And this is just my structure, right? And then also within 102A I have a folder for lectures and stuff like that. And I like having everything nicely organized. So anyway, here's my homework 1 folder, and I've got a bunch of files in here. But let's say you are going to open up this file, output Joe Bruin, okay? And one thing is I have a dark theme. You can change your appearance under Tools, Global Options, okay? Under Appearance, you can choose a different theme, right? I think the default is this light theme, and that's fine, okay? But I like maybe a little bit of a darker theme. I use Cobalt. You use whatever you want to use, okay? All right, so this is what it looks like for me. And as far as once you open your file, because you're gonna have to reference objects and stuff from that thing. Let's see. So under homework 1, right, there's different files, right? You got to like reference month names and stuff. So download this and put this in your homework 1 folder, and you'll do session set working directory, and you're going to do to source file location. And if your homework 1 folder has that stuff in it, then it will reference it correctly. Okay, so you're going to go to session set working directory. All right, so this is what I have here, and I think that will help you kind of keep your stuff organized. Otherwise, you're going to run into problems later on when it says things like load this script and load this reference this thing. If you didn't have this properly set, okay. So one of the things down here, scroll out. Where did it go? Okay, so like when you try to read this thing, right? So here it loads and it reads. But if you didn't have it, right? Like if that file, if I had set the working directory to something else, right? If the working directory set something else and you try to run this, you're going to run into this problem, right? You're going to get this cannot open the file, no such file or directory or something like that, okay? And that probably means you didn't set your working directory correctly, and or the file's not in your working directory or something like that, okay? You set your working directory, and again, session set working directory to the source file location. Make sure all your stuff is in that folder, and it should work, okay? And that should get you working, okay? Another thing, sometimes when you knit, right? Oh, this is a common thing that students will tell me. I'm able to get the code to work, You know, when I'm working here, I can run the code over here, but then when it comes to knitting, it doesn't knit, okay? What often happens is that, you know, you're working and maybe somewhere along the way, you create this value, okay? And it shows up here. And then when it comes to knit, you know, you have a line that says like print K, right? And then so I can, and when I try to knit this, okay, well, actually, I need to turn this to error, false here or something, right? If I try to knit this, I run into this thing and it says object K not found. Okay, and I go, well, I don't understand because if I run this over here, I'm able to, I can print K. K exists right here, number 19, right? And the issue is that as far as this code goes, I never created the value K inside my inside the instructions in the RMD file. And so here it's trying to print out the value K, but it never printed, I never created K. I created K inside the console, but not in the instructions here. And the idea is when you are knitting, it starts off with an empty directory. And so what I always encourage students is delete everything in your environment, okay? And to delete that, you click this broom button. The broom button will delete everything. Are you sure you want to remove all the objects? Yeah, we're going to say yes. Remove all the objects from your environment. And then if I try to run this, now I run into the problem, okay? Object K not found. And then we go, oh, you know what? You're right. I never set K into a value, okay? And now I can do, oh, okay, K is 19. And now it's gonna, and now it will work, okay? Now it will work without error, and I can knit this, okay? Whereas before, you know, I had created a thing, but it didn't work. So sometimes you will kind of, you know, as you're working, you create objects in your console. And so they show up in the environment. And when you run your code, they reference the values in your environment. And so you think everything is working. But when it comes time to knit, what knitting does is it basically starts off a fresh environment with nothing in it, and it tries to run every single line of code, all right? Because the idea of R Markdown is that it wants to create reproducible research, meaning you can give this Markdown file to someone else, and they could run it on their computer with nothing in their environment, and it's going to run, all right? And so if you click knit and it's not running, but if it's running over here, but it's not running when you knit it, that probably means you have values in your environment that you created somewhere along the way, but you didn't write the instructions for creating that value inside the Markdown document. Okay, I hope that makes sense, right? And so, so just kind of, so to troubleshoot, delete everything out of your environment, run the code, and then you'll probably encounter the same same problem, and then you can probably narrow down what the problematic line of code is. And I closed today's lecture. Where did it go? Okay, hang on a second. Okay, so you can click the environment and you know, just review some of these notes on your own time to kind of make sure all of this makes sense. Okay, another way to clear the environment is to do rm list equals ls, and that will delete everything out of the environment. Oh, another thing, this I strongly recommend, under global options, make sure these two settings are in place. This should be unchecked, restore R data into workspace at startup. That should be unchecked. Save workspace to R data on exit. That should be set to never. Okay. And the reason for that, okay, because I think a lot of times you have kind of the opposite where it'll like save things on exit and restore your workspace. And that often works because it's like, you are working and then you close R, and then when you open it back up, it's like picks up right where you left off, and you go, oh, this is great. Okay. But sometimes you have to reboot your computer. Sometimes something goes wrong and it crashes. And when you open things up, maybe things are the way you left it. Maybe things are a little bit different. And if you created something and you're in some kind of, weird save state, things might not work the way you want them to work. By unchecking this, it forces you to be explicit about when you want to save your files. Okay, it forces you to save everything so that you can reference them later. Okay. Hang on a second. And so not saving on exit forces you to have good save habits, right? And sometimes you'll have old values that are incorrect that kind of interfere with your current script and things like that, right? So, often there's certain variable names that we frequently use, like X and results and I and things like that. And sometimes if you have all of these things saved, they could throw off the new results and stuff. So don't save your workspace on exit. Don't restore your workspace when you start a bar. Oh, another quick little shortcut is as you're working, you can take lines of code and you can hit Command-Shift-C and it will just comment them out, and Command-Shift-C to uncomment. Okay. I mean, you can individually type the hash mark there and it will comment or uncomment them, but you can just take entire chunks and just Control or Command-Shift-C to comment them out or not. You can create new scripts by hitting this drop down and doing Control-Shift-N or R script, and that will create a new script. As you are scripting, okay, you can take lines of code and run them by highlighting them and hit Control or Command-Enter. You can you can just go line by line, Control, Command-Enter. You can highlight everything and hit Command-Enter, and it will run all of these things. You can also just click Source, and it will run everything. There's a whole bunch of ways as far as running all of these things. Okay. Oh, and if you want to delete objects one at a time, you can switch from list to grid, and you can just like put a little check mark. I want to delete Y, hit the broom, and it will wipe that out. Or in list mode, which is normally how it is, you just delete everything. Okay. So yeah, you can source your entire script, Command-Shift-S. Quick things, you can clear the console. So as you're working, this can get cluttered. And there's a few ways to clear the console. You can hit the little broom here, or you can hit Control-L on your keyboard, and that will clear out the clutter down here. Restarting R, that's a keyboard shortcut, and knitting is Control-Shift-K or Command-Shift-K, and you can click knit. Okay, any questions before we move on to kind of more content and stuff? We feel good. I recommend you review these notes because I think they're good tips. They're tips that I thought like, oh, if someone's starting to, do a little bit more work in R and R Studio, these are some of the things that I think are nice features. Okay, let's start talking about basic data structures. This is going to serve as a bit of a review. Let me give you your first view quiz answer for today. This is week 1 Wednesday, and let's see, your first view quiz answer is A. A as in apple. A as in apple is your first view quiz answer for today. All right, and so I think you should have learned all of this stuff I'm going to look at today in Stats 20. And for some of you, you took Stats 20 last quarter. And so this is fresh in your memory. And for some of you, you might have taken Stats 20 several quarters ago. And so you're a little bit rusty. Maybe some of you have been coding a lot since your Stats 20 class, and others of you have not touched R since you finished Stats 20 several quarters ago. So this will hopefully be a quick refresher on everything and get you back in the swing of things. Number one, do you remember what is the main difference between an atomic vector and a list? What is the primary difference between an atomic vector and a list? You can just unmute yourself. Go ahead.
Atomic vector has all of them of one type, like either
Yes.
character or numeric, or yeah, and list has multiple. It could have multiple, I guess.
Yeah. So a list does not restrict things to be of the same type, whereas an atomic vector, all elements of an atomic vector must be of the same type. And so as far as atomic vectors go, there's 6 basic types, and pretty much most of the time we really just work with these first 4. So you've got the logical, which are the Boolean values, your true, your false values. Doubles are numbers. Integers are also numbers, but they don't have any decimal places. Characters are for text. Okay. And as far as doubles and integers go, the conversion between integers and doubles, like these different numeric types, that happens automatically in R. And this is a nice little feature, especially if you're a statistician and you don't want to have to worry about these things. But if you're a CS person, this might feel uncomfortable, especially if you're coming from some kind of language like C and things like that. The way R converts between type double and type integer might feel uncomfortable. That this is a design choice of the creators of R. We have a question that says, what are complex and raw? Complex numbers have an imaginary component, right? So sometimes you have to work with the imaginary plane, and so you'll have numbers like 3 plus 2i and stuff like that. That will be a complex number. And then raw is kind of the way we represent certain values with a hexadecimal number in memory. And so it'll be like if you do like so the number 5 is that, but then if you do like the character H, is that not right? Sure. Okay, maybe. Okay, so I think this is. So it's hexadecimal representation, but then I'm pretty sure we can also represent characters as raw, but I forget how to do it. Anyway, it's like hexadecimal representations of certain things. We don't really worry about it too much though. Okay. When you use the colon operator, like if you do something like 1:10 and you create this vector, this is an integer. This is a sequence of integers, which is separate, which is different from doing something like this. Okay, these two things are not identical. This is type double. This is type integer, even though they look identical here. Okay. If you want an integer, you can type in an L. This is an integer 1. And so you can ask, is the number 1 identical to this? And it's not, right? I can say X is equal to 1 and Y is 1L. Okay. And these two things are not identical. Okay. X and Y are not identical, right? Versus identical X and 1 is identical. Y and 1 are not, even though X looks like this and Y looks like this. Okay. And that's because X is type double 1 and Y is an integer type. Okay. Is it important to know which outputs will be double versus integer? On a practical basis, no, not really, because R is just going to convert things between integer and double. But there are a few, maybe some edge cases where it does play a role, but it is important to know that R stores these things differently. Okay, and we'll get into how floating point numbers work. Okay, because type double is a floating point number, meaning you can store decimal values, and there are some interesting properties, and we'll talk about that maybe like in week 6. Okay. So anyway, yeah, 1, 2, 3 is a double. 1:3 is integer. 1 is double. 1L is integer. When you have a list, you can have different types. Okay, and so we say the one-dimensional structure, heterogeneous, meaning you can have different types. That's going to be the list. Whereas if it's homogeneous, everything's of the same type, that's an atomic vector. If you want to add a second dimension to it, you can have a matrix. Everything in a matrix has to be of the same type. Whereas if you got different types, so you can think of a data table, data frame. One column is age, numbers. One column is a name, so that's character type. One column is gender, which maybe is categorical. Okay. And so that could be stored as a factor or something. You got different types of data in there. That's going to be a data frame heterogeneous. You got different data types. If you want something in higher dimensions, like a 3-dimensional data structure, okay, maybe like a tensor or something like that, or an array, that's going to be n-dimensional, and everything has to be of the same type. We don't have anything that exists like that for different data types. In any object in R, so vectors, data frames, anything, okay, can have attributes. Okay, you can have attributes. An attribute is basically a list of whatever information we want to put in there. Okay, any information you want to put into the attribute, you can put it in there. Now, there are certain attributes that are important, like the dimensions and the class and things like that. Those are probably the most important attributes that we store, but you can put in any kind of things, right? So I've got some questions here that you can answer yourself when you're reviewing these notes. So if you want to work with the attributes, the function you need is attr, and that's going to pull out one attribute, and it will allow you to kind of change the values of an attribute. If you want to just kind of see all of the attributes all at once, you can just use the attributes function. So there's a data frame in R called trees. This is just one of the built-in data frames. Trees here, 31 rows, 3 columns. Okay. And we can ask, hey, what are the attributes of this thing? Attributes of trees. And this will list off all of the attributes. The attributes, we have the names, which are basically the column names. We have 3 columns, girth, height, volume, those are the column names. What class of object is this? This is a data frame, data.frame. And it tells us the row names. There are 31 rows, and each row has its own name. And those names are just the integers 1 through 31. Okay. And so when you ask for the attributes of this data frame, it tells us what it is. Okay. It just lists out the attributes. Now, if we wanted to, we could do this. I don't know if it makes sense to do this, but there's no rule against it. You can set attributes. You can do attr. Trees, I want to add a new attribute, info. Okay. And we can just write whatever, right? This is a data frame about trees or something. Okay. And so now if I ask, what are the attributes of trees? That additional piece of information is here. And you can just add whatever you want. You want to add a function to it? Go ahead. Okay. Now, we probably don't really do that, but there's no rule against it, and you can do it. Let's see how attributes play a role for something like a matrix. Okay. So here I'm going to create a vector 1 through 10, an integer vector 1 through 10. Here's n. Okay, it's a vector, values 1 through 10. And I can say, hey, what is the class of this thing? Okay, it just says, oh, it's an integer vector. Okay. Are there any attributes? No, no attributes right now. Okay, but I can set an attribute. I can set a dimension attribute. Okay, we're going to take M, set the dimension attribute. I'm going to give it the dimensions 2, 5. Right. So now what are the attributes of M? Oops. Okay, now it has the dimension attribute 2, 5. Okay. What does M look like? It has now converted M from this vector 1 through 10 into a 2 by 5 matrix. 2 rows, 5 columns, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in this 2 by 5 matrix. Okay, so M is now a matrix. If I ask what is the class of M, it's going to say, oh, it's now a matrix. Because that's really all that separates an integer vector from a matrix, or just any kind of vector from a matrix. So the attributes of M, there's now dimension attributes, and it's a matrix. Now, if we want, okay, so M is a matrix now. I can say, what are the attributes of M? Typing, it's got this. I can take that attribute, that dimension attribute, and I can just delete it by setting it to null. I can say this thing no longer exists. Okay, what are the attributes of M now? There's nothing. And what does M look like? It's back to just an integer vector, 1 through 10. Okay, so if you take M, so notice the internal data, the values inside M never changed. But the way it was structured, the way it appeared, differed by applying this dimension attribute or taking it away. Question, is this different than levels? So levels in a factor are an attribute, but the dimension attribute is something different. So levels are stored in a factor by using the attributes feature. If we type dimension instead of dim, will it still work? I don't think so. I don't think so. Dimension. I don't think this function exists. Yeah, it's going to say this function doesn't work, right? So we just use dim. There's no dimension here. It says there's no dimension, but there's no dimension there's no function called dimension here. Now we could create a function, right? Or basically now I've created now I've created a function, an alias for it, but that's dumb. Okay. Okay. What happens if you assign NA instead of null? Okay, let me get into the difference between NA and null in a moment here. Okay, that comes later. All right, arrays are basically matrix which has more than 2 dimensions. So everything, it's an atomic vector, but the dimension attribute has more than length 2, right? So here, if I say the dimension attribute is 2, 3, 2, this is going to create an array, like a 3-dimensional grid of numbers, where you've got 2 rows, 3 columns, and like 2 layers or 2 sheets. Okay, 2 sheets of values, 2 layers of values. So 2 rows, 3 columns, and 2 layers of values. So notice the rows are 1 comma, the columns are comma 1 or comma 2, comma 3, and then the layers are comma, comma 1. So this is, what is the coordinate of the value 6? The coordinate is 2, comma 3, comma 1. What's the coordinates of 9? 1, comma 2, comma 2, right? So if you're trying to locate where this thing is in this solenoid of values, you'd say, I want to go to the second row, first row, second column, second layer. First row, second column, second layer is the value 9. Data frames are lists, allowing us to have different types, but they're arranged in columns. And but the columns have to be of the same length. Otherwise, it's not going to be a nice two-dimensional structure, right? So, you know, if you have 31 values in the first column, then the second column has to have 31 values. Otherwise, we run into problems. So trees has 3 columns. It's a data frame. Internally, though, it's stored as a list. It's a list of 3 vectors. Each vector is of length 31. A factor is another data type. Internally, it's stored as an integer, but factors are used for categorical variables. Okay, so you think about a categorical variable, you got different categories, and we're storing it. So here we might have gender. We've got this vector with M and F and X maybe for someone non-binary, maybe someone who didn't want to respond. And we can turn this into a gender, okay, gender factor, all right? And so these are the different levels, and our defaults to putting these things in alphabetical order, but you can set the order yourself. And so we're gonna, F is the first level, M is the second level, and X is the third level. And so this vector is stored as a factor. We can ask, what are the levels? Okay, that's an attribute. The levels are F, M, and X, all right? And if you ask, what is the type of for the factor? Internally, it's stored as integers. So what's going on is that internally, the values are M is the second level, so it gets stored as a 2. F is the first level, so it gets stored as a 1. So the values M, F, F, X, M, F is 2, 1, 1, 3, 2, 1. If you ask, what are the attributes of this object? The attribute says, hey, it's a factor class. And inside there, we've got the levels F, M, and X. And this is how it kind of stores all of this. And this was important, you know, back in the day when like memory was restricted and you didn't want to like waste time and stuff. And you know, you can kind of it's a way to kind of abbreviate and store values this way. Now, so because things are stored as factors and are stored as integers in a factor, there's a few strange things that could happen, right? So if you decide to take some numbers and make a factor out of it, you're basically saying these are categorical values. Okay, categorical values. Okay, so I don't know if you ever play tennis. Okay, now when you play tennis, I think it goes like 0. The scores, how do the scores in tennis go? It's like it goes 0, 15, 30, 40 game. Is that how it goes? Okay, and so it doesn't quite make sense to say if one person has 0 and the other person has 30, it doesn't make sense to say, oh, he's 30 ahead of the other. Okay, or if somebody is at 15 and 40, you don't say he's 25 ahead of the other or something, right? Because those things, 0, 15, 30, 40, those are not, they don't represent numbers, right? It's just another way of kind of keeping track of like, you're at 0, 1, 2, 3, and game, basically. And similarly, if you do take this with these numbers and you turn them into factors, they lose their numeric meaning. And so if we were to take this, and if I were to say, hey, what's the mean here? R is going to say, you can't take a mean of a factor. It's a categorical variable. You can't do that. Now you can say, well, I really, really want to find the mean. And so we're going to take the factor and we do as numeric. As numeric on the factor and say, give me the mean of this. It gives me back 2.5. 2.5, 0 plus 1 plus 10 plus 15 adds up to 16. 16 divided by 4 is 4. Why am I getting 2.5? Okay. Well, remember the factor is stored internally as integers. And so 0, 1, 10, 5 with the levels, 0, 1, 5, with these levels, internally it's stored as 1, 2, 4, and 3. And so when you ask, what is the mean of 1, 2, 4, and 3, the mean of that is 2.5. Does that kind of make sense? Why mean of this factor is coming out as 2.5 rather than 4, right? And sometimes we forget that this is what's going on. And so we'll be tempted to just do as numeric X factor. And now it's obvious with these numbers, but if you've got like a big column and its factors, you might not realize that you've done something wrong. And this is like the scary thing, right? Is maybe you've done this and you get this number 2.5 and you think this is the mean, but you didn't actually realize you've made a mistake and you're operating with this number, and that's actually a mistake. If you wanted the mean of these numbers, 0, 1, 10, and 5, what do we have to do? First, we're going to convert them into characters. And then we get character 0, character 1, character 10, character 5. And then we say, turn those into numbers. And then character 0 becomes 0. Character 1 becomes 1. Character 10 becomes 10. Character 5 becomes 5. And then we can take the mean of that. And 0, 1, 10, and 5 add up to 16 divided by 4, and we get 4. But again, when you have numbers and you say these are categorical variables, that means there's no numeric value to the numbers itself. So think of your area code. On your phone, you have an area code. Maybe you have area code 213, your friend has area code 818, someone else has area code 562 or something like that, okay? Does it make sense to compare your area code with someone else and say, oh, I have 700 more area code than you? That comparison doesn't make sense. It's a nonsense comparison, right? It makes sense to compare like how much money you have in your bank. I mean, you shouldn't do this. This is how you lose friends. But you can say, I have $30 more than you in my wallet. Okay, that's fine. That number has numeric value. Okay, and you can say I'm 2 years older than you. Okay, you can compare your age, and that has numeric value. But comparing your area code, there's no numeric value there. Okay. And basically the area code is a categorical variable. It's not, there's no numeric meaning to it, okay? And similarly, when you say something is a factor, you're saying there's no numeric meaning to it. It doesn't make sense to compare the values. It would be like model numbers on the car, right? Is the like, the BMW 530, 200 more than the BMW 3 something, okay, right? You get these different model numbers for the car. It doesn't make sense to compare those things, right? Or is stats 102 2 more than stats 100? Okay, these comparisons don't really make sense. Okay, so because of that, weird things happen when you try to do stuff with factors. You try to combine them, you can't. Okay, you try to put in a value that doesn't exist in factor, you're going to get a warning. It's going to produce an NA. Are coercive values? Well, I got to talk faster here. And it does coercion automatically. So atomic vectors have to store everything of the same data type. And so when you combine vectors of different types, it's going to coerce or convert everything into the least restrictive type and combine them all. So here I've got a logical vector with true, false, integer vector with just the number 1, L, double vector with 5, 6, 7, character vector with the values letters A and letter B. When I combine the logical, integer, and double is the least restrictive, 5, 6, 7 is the least restrictive, and we would add the logical, the true, false gets coerced into double, so the true becomes 1, the false becomes 0, and now we get this 1, 0, 1, 5, 6, 7. If we combine the logical, integer, and character, the logical with true, false gets coerced into character. So true gets character quotes put around it, false gets characters put around it. And so now we have true, false, the integer gets quotes around it, the 1 gets put quotes around it, and A and B. And those get combined that way. Coercion just happens kind of automatically or implicitly when you ask it to do stuff like sum or take the mean. So you can imagine some logical vector. These could be the results of some kind of experimental trial. and we get false, false, true. And if we were to ask for it explicitly as numbers, false becomes 0 and true becomes 1. So we get 0, 0, 1. But if we just said, hey, give me the sum of false, false, true, it's going to say, oh, the sum is 1. What's the mean of false, false, true? The mean is 0.33, okay? Because basically it's converting it into numbers first. What's the sum of 0, 0, 1? 1. What's the mean of 0, 0, 1? 0.33. This is basically the proportion that's true, the total number of truths. So it's nice. It's nice. It does it quick. It's on the fly. It's great for statisticians. Often makes computer scientists uncomfortable because it's kind of doing this automatically without you explicitly saying these things. You can explicitly coerce. You can say, I want my true false vector to be characters. Okay, I want my numbers 0 and 1 to be turned into logical values, false and true. If you ask it to convert something that it doesn't know what to do, right? Turn capped into a number. It's going to say, oh, I don't know what you're talking about. All right, I don't know what to do. Here's a missing value instead. What's the order it coerces in? Again, it goes from least restrictive to most restrictive. It's going to look at the least restrictive type and do that. And it's on this slide right here, slide 32. Here are some rules on coercion. Anything for coercing a number to a logical, zeros become false. Anything that is not 0 becomes true. So that includes -1, 0.12, negative infinity, something very close to 0 but not 0. Those all get converted to true. NaN, not a number, gets coerced into NA. Everything else, 0 becomes false, everything else becomes true. If you want to turn words into logical, these are the accepted spellings. So capital F will become false, all caps false, capital false, lowercase false, those convert to false. These become true, okay? Lowercase f by itself won't do. Lowercase t by itself won't do. Things like cat won't work. 0 and 1, why didn't it 0 and 1? 0 and 1 converted to false true here. Why aren't they coercing the true, false true here?
Because they are characters now.
Yeah, they got coerced. When I combined them with the characters, these 0, 1 got coerced to character 0, character 1. And now they will not convert to false true. Okay. All right, what's the difference between NA, null, and NaN? NA is for missing values. So these are values that exist, but we don't know what they are. That happens a lot. Null is for something that does not exist. Okay. So you could think of, maybe you're keeping track of information on some people or families or households or something. And so you have a spot for the primary person, and then you maybe have a spot for the partner. Okay. And so you can say, what is the age of the primary member of the household? Okay, whoever's designated the primary person in the household. Okay, so the primary person, that person, if they exist, they have an age. Maybe you don't know the age. If you don't know the age, you write NA, okay? That person may or may not have a partner. So if the person does not have a partner, and you say, what's the age of the partner? You would put null. This is for somebody who does not have a partner. Okay. If the person does have a partner, but you don't know the partner's age, you use NA, okay? NA is for something that exists, but you don't know what the value is. Null indicates that this thing does not exist. So if there's no partner, then that person doesn't exist, and that person won't have an age, so that's going to be a null, okay? NaN is something that shows up when we're dealing with type doubles, and this is going to be the result of some kind of indeterminate form of math, right? You try to do 0 divided by 0, you're going to get something that in some indeterminate form, you get NaN, okay? Or you do, what's negative infinity plus positive infinity? NaN, okay, we don't know. NAs can be inserted into any type of vector, and so they will not change the data type. So you have an NA of each different type. You have a logical NA, which is the standard NA. You have an integer NA. You have a type double NA. You have a character NA, and that way NAs can be inserted into each any kind of vector, and it doesn't change the type. So what happens when you take the regular NA is logical NA? What happens when you insert it into character into a type double? It gets coerced into the NA underscore real. Okay, that's technically what's happening. When you want to check for something, if it's missing, don't use equals equals. Equals equals is asking, is this thing equal to another? Again, remember, the thing is unknown. So if I say here, I have an unknown value in my hand, I have another value in this hand, are the values in, is the value over here equal to the value over here? And the answer is, I don't know. So your answer is going to be NA, right? Person number 1 is X years old. We don't know the X. Person number 2 is Y years old. We don't know Y. Is X equal to Y? I don't know. Okay, we don't know. All right, but we can say, is X missing? Is X a missing value? That's is NA. That's going to be true. So is NA is true. Again, null is used to represent things that don't exist. It's its own type. So if you say, what's the type of null? It'll be the null type. And you ask, is it null? That's going to be, you have to use the is.null function. You can't say, is it missing? Null is not a missing value. It is a non-existent value, all right? And the result of is NA null is going to be a logical vector, but of length 0. If you try to put null into some kind of vector, it's just not there. So you do 4, 5, null, and 3. It's the same as 4, 5, 3. Okay. Null is its own type, so it's not a logical value. If you try to combine null, do operations with null, you're going to get a length 0 vector. Okay. So null plus false. False gets coerced into an integer with the plus sign. So you're doing null plus 0. You're going to end up getting a length 0 value. Okay, and you can't do these kind of comparisons either. I think we're familiar with this concept of vectorized arithmetic. Oh, how many view quiz answers have I given you? 1. Oh man, I'm the worst. Okay, let me give you view quiz answers 2 and 3. You guys got to help remind me. Just if it's like 11:35 and I haven't given you a second answer, just hey, what's the second answer? Okay, second answer is B. B as in bear. B as in Bruin, B. And then the third answer is E, E as an elephant, E as an elephant. Okay. So yeah, if it's like 11:35 and I've only given you 1 so far, ask for the second one. And then, yeah, anyway, okay. So those are your second and third view quiz answers. And make sure you remember to answer them. Okay, so arithmetic is vectorized, meaning we'll do like the first with the first, second with the second, third with the third. So when you add them, you get 101, 202, and 303, and stuff like that. They're also recycled. So when you do 1, 2, 3 plus 100, 200, 300 through 600, you get 100 gets the plus 1, 200 gets the plus 2, 300 gets the plus 3, and then it recycles around, it loops around. 400 gets plus 1, 500 gets plus 2, 600 gets plus 3. Okay, and so you get that 101, 202, 303, 401, 502, 603. Same thing over here, 101, 202, 303, 401, 502. But then R says, you know, I ran out of values. Okay, I'm not sure if this is what you wanted to do. All right, and so it says, you know, the longer object is not a multiple of the shorter object. It says I did it. I did it. I hope this is what you want. I hope I made you happy, but I'm not sure. So here's a warning, okay? And sometimes it does do what you want it to do, and sometimes that's not. All right, when you recycle with a matrix, it recycles column-wise. So here's the matrix. I'm going to add the vector 100, 200, 300, and it goes down the column. It adds 100 to this value, then it goes to the next value, 200 to the 4, 300 to the 7, 100 to the 10. And then it keeps recycling, 200, 300 to the 5, 100 to the 8, 200 to the 11, 300 to the 3, so on and so forth. And you say, well, no, what I wanted was I wanted to go 100, 200, 300 across the rows. Okay, if you wanted to do something like that, you can transpose and then add column-wise. So now we've transposed it. We're going to add column wise 100, 200, 300, 100, 200, 300, and then we can transpose back. Okay, and then we can get what we want. Okay, that is it for today. You should be able to at least just get started a little bit on your homework if you haven't done so already. And other than that, have a good day. We will see you guys on Friday. So yeah, have a good day.